Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been looking at factors of numbers. We have been looking at prime numbers and composite numbers. Now we have started to look at prime factorization of numbers. Now, prime factorization is a fancy way of saying you can write any composite number as a multiplication of all prime numbers. And the reason we do this, well, there's many reasons in mathematics we can use prime factorization. But for grade 6, it can really help us get all of the factors of a number. Now, we should recall, if we go back in time, that a composite number has more than two factors, and a prime number has the factors of one in itself. It only has two factors. Now, one of the activities we had done recently was we had done the sieve of Erasthenes to find all the prime numbers less than 100. Now what we're doing is we're going to do prime factorization. We're going to be using our knowledge of prime numbers to break up composite numbers into all multiplications of prime numbers. Let's take a look with a small number. So what we're going to do here is we're going to make something called a factor tree to show the prime factorization of a number. We'll start with 12. And so what we do is, it's called a factor tree because we'll draw a couple branches down. And we want to think of two numbers that multiply to 12, except we can't use 1 and 12. The reason we can't use 1 and 12 is 1, actually, we talked about the other day, how 1 is neither prime nor composite. So we want any pair of numbers that will multiply to 12. So let's say we did 3 times 4. Okay, now we know from an earlier class that 3 is a prime number, so we're done with 3, and we'll just bring it down. All right. Now, 4 is not a prime number, it's a composite number. So we'll break up 4 into another multiplication, but we can't use 1 times 4, and the only pair we can use there is 2 times 2. Now, what we have now is 12 written as a multiplication of all prime numbers. These are all prime numbers. 3 is a prime number, and 2 is a prime number. And they multiply to 12. Well, la-di-da, right? But what are we going to use that for? Well, we can use that to find all the factors of a number. So, first of all, if we want to find all the factors of 12, we know that the first pair are 1 and 12. We don't need the factor tree to do that. Now, let's look at the bottom row on our factor tree, and let's look at just the single numbers. We have a single 2. That means 2 will be a factor. And we have a single 3. That means 3 will be a factor of 12. We might know these already, but that's okay. So those are all the single numbers. Now let's look at the pairs we can make. Let's look at the pairs of multiplications. 2 times 2. That'll give us the factor 4. And then let's look at a different pair there. 3 times 2. That'll give us the factor 6. And those are all the factors of 12. The last one would be to do the group of 3, and 3 times 2 is 6, times 2 is 12. So all the factors of 12 are 1 times 12, 2 times 6, 3 times 4. We were able to create all those numbers from the prime numbers here. So that's how we can use factor trees to help us obtain all the factors of a number. Let's look at another one. 18. Okay, well, let's think of two numbers that multiply to 18, but we can't use 1 times 18. So let's use, 2 multiplied by 9. Now 2 is a prime number, so we're done with it, but we're going to bring it down with another branch. 9 is not a prime number, so we want to break it up into another multiplication. Preferably, we can't use 1 times 9, though. So the only pair left is 3 times 3. Now, this bottom row on our factor tree is all prime numbers. 2 is a prime number, and 3 is a prime number. And we can use that to find all the factors of 18. Well, we'll start with 1 times 18. We can't use the factor tree to do that. But now let's check our single factors at the bottom. Well, we have a 2. That means 2 is a factor. We have a 3. That means 3 is a factor. Now let's look at our pairs. Well, I see 2 different pairs of multiplications here. I see 2 times 3. Oops, I forgot to write my 3 down. So I have a single 3 as a factor. Now let's look at our pairs. Well, we have 2 times 3, which is 6. And we have 3 times 3, which is 9. And those are all the different pairs we can make. The last multiplication we could do would be to multiply all 3 of them. And when we do that, 2 times 3 is 6, times 3 is 18. And we have all the factors of 18 now. Now, we might not have needed to do this, but it definitely helps us with larger numbers. Let's do another one. We'll do one more with small numbers here. So we probably know all the factors of 20, but let's do it anyway. Let's break 20 into its prime factors. So we're going to start off with any pair of numbers that multiply to 20 except 1 times 20. I'm going to do 4 times 5. You could also do 2 times 10 and you'll get the same thing. Now, 4 is not a prime number. 4 is composite. So I'm going to do 2 times 2. 5 is a prime number. So I will bring that down. It's done. And now we have all prime numbers at the bottom of my factor tree. 2 is prime and 5 is prime. Let's use those to get all the factors of 20 now. And we might know all the factors of 20, but let's just try it. So the first pair of factors that multiply to 20 are 1 times 20. The factor tree doesn't help us. Do you do that? Because 1 is not a prime number or a composite number. Now, let's look at the single factors. There's a single 2, right? There's 2 2s, so we have a single 2 is one of our factors. Okay. We have a single 5. So 5 must be one of our factors as well. Now I know there's a number in between here, so I'm going to leave a bit of space. Now let's look at our pairs that we can get from this bottom row. Well, I see a 2 times 2. Well, 2 times 2 is 4. So 4 must be a factor. And let's look at another pair. Another pair I see a pair of 2 times 5. So that means 10 is a factor. And those are all the different pairs we can make. And the last thing we can do is multiply all 3. 2 times 2 is 4, times 5 is 20. And there are all our factors of 20. We got that by getting the prime factorization of 20. Fancy word. Let's look at something with a bigger number here. Let's not look at 24. Let's go larger, past 36, 45. Ooh, let's try 60. Okay, 60, huge number. There's a lot of factors for 60. We might not know them all, right? Like it's some of these ones require some bigger multiplications. So let's try doing the prime factorization. Break 60 into 2 numbers that multiply to 60, except 1 times 60. The one that pops into my head right away is 6 times 10. Now, 6 is not prime, and 10 is not prime, so we have to keep going. 6 can be broken up into 2 times 3. Yay! This is prime, and this is prime. 10 can be broken up into 2 times 5. Yay! This is prime, this is prime, this is prime, this is prime. Now, a lot of people go and write these in order from smallest to largest, so what we could say now is that 60 equals 2 times 2 times 3 times 5. Those are all the factors, that's the prime factorization of 60. That's 60 written as a multiplication of all prime numbers. Now, we can use these to get all the factors of 60. And there's a lot of them. So let's start with 1 times 60. Now that doesn't, the factor tree doesn't help us get that, but we just know that, right? Now let's use the single factors now. The single ones, I see, there's a 2, there's a 3, there's a 5. So we know 2 will be, we know 3 will be. I know a little something else here, so I'm going to leave a little bit of space. We know 5 will be. Okay, now let's look at the pairs of numbers we can multiply. Well, I see a 2 times 2, which is 4. That's why I left a space there. I just knew that was coming. Okay, what else do I see? Well, I see a 2 times 3, which is 6. Okay, do I see any other pairs there? I see a 2 times 5, which is 10. All right, now I've got to look at my groups of 3 numbers now. Look at all the combinations of 3 numbers. Well, the first one that I see is 2 times 2 is 4, times 3 is 12. So 12 is a factor of 60. And I see a 2 times, pardon me, one pair of numbers that I missed was I missed the 3 times 5. So 3 times 5 is 15. I'm going to erase this 60 because I'm going to need a bit more space. There are so many factors here. Now another group of 3 I can see. I had 2 times 2 is 4 times 3 is 12. Well, I can also do 2 times 2 is 4 times 5 is 20. So 20 is a factor. Now, let me just check here. Okay, I've got 3 times 20. I've got 4 times 15. I've got 5 times 12. I've got 6 times 10. I need a pair that goes with 2. Well, I know that I've got 2 times 3 is 6, times 5 is 30. So there's 30. And then, of course, I've got my factor that pairs up with 1. That would be 60. So all the factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. So that's how making a factor tree can help you get all the factors for one of these really large numbers. Because a lot of us don't know a lot of these multiplications, right? But we can figure them out. That's one of the reasons we use prime factorization or factor trees, and we use them all throughout math. So I hope this video helps. We'll be doing more practice with factor trees and prime factorization. That's all for now. Flexing Teacher Weber, out.